Okay, so in this tutorial, we're going to be talking about three new concepts, which is total float, free float, and independent float. And before we actually start to understand what floating points actually are, in PERT analysis, the first thing that you have to understand is what is the earliest and what is the latest time in each and every, for each and every single node in PERT analysis. So if you're intimidated by looking at all these formulas, and if you're getting confused, you don't have to be, because the moment you see an example and you see how this is actually analyzed and done, you're going to notice that these formulas are actually pretty much self-explanatory, and you're going to be able to by heart them very easily. So the way we're going to do this is we're going to look at an example with some activities and durations, and we're going to draw a network diagram for it with the durations, and then we are going to figure out what the earliest and latest times are for each and every single node in that network diagram. And once we have done that, then we're going to go to the total float, free float, and independent float concepts. So let's go ahead with the example. So I've taken an example over here, which is activities and durations. Okay, and this is the number of activities that we have for this example, and these are the durations for each and every single one of those activities. And over here, I've taken the liberty of drawing the network diagram, and I've already marked the critical path for this network diagram. Now the critical path is not exactly necessary for this problem, but just for the sake of making sure that we cover all the concepts of PERT analysis, I have drawn the network diagram and the critical path, and I've given the duration for each and every single activity as has been shown in the question. So now we're going to move ahead and understand what earliest and latest times are. So the earliest starting time is nothing but what is the possible date or what is the possible time which is the earliest possible to start an activity. That's all it is. Okay, and the latest completion time is nothing but the latest completion, the most possible completion time for each and every single node or each and every single event in the activity. So let's just go ahead and see this example right here. So the first node, for the first node, you're always going to have a default value for the earliest time, which is going to be 0. Okay, and we are going to be putting the earliest times in the lower box, and we are going to be adding the latest times in the upper box. Earliest time in the lower box and latest time in the upper box. Okay, so for the first node, the default value is always going to be 0. So 0 is the earliest starting time. And now we are going to be using from here on what is known as a forward passing method. And forward passing method is nothing but you simply take the earliest time of your previous node and the duration of the activity, you add them together, and that is going to be the earliest time of your second node. So the second node here is 2, and the duration from activity 1 to 2 is 5, and your earliest time is 0. So simply 0 plus 5 is going to be 5. We're going to add that as the earliest time for 2. Now we move on to the node number 3. Similarly, for node number 3, we have the earliest time of the predecessor as 0, and the duration is 4. So 0 plus 4 is going to give us 4. Now if you notice node number 4 is not any normal node. It is actually a merge event. And a merge event is basically an event in which more than 2 activities collide. Okay, so as you can see, activity 3 to 4 is colliding into this event, and activity 2 to 4 is also colliding into this event. So how are you going to add the earliest possible time here? Once again, it's pretty simple. First of all, let's just go ahead and analyze the situation. So for the predecessor 3, you have the earliest time as 4, and you have the duration as 2. So 4 plus 2 is 6. For the predecessor 2, you have the earliest time as 5 and the duration as 6. So that's going to be 11. As you can see, 11 is greater than 6. So whatever the greater value, that's what you're going to be taking in the forward passing technique. So over here, we're going to add 11. Now we move on to node number 5. And node number 5 is going to be 11 plus 1. That's 12. Node number 6. This is going to be, once again, 11 plus 7, which is going to be 18. Okay. And then we move on to node number 7, and node number 7 once again is a merge event, as you can see. So 18 plus 4 is going to be 22, 12 plus 8 is going to be 20. So we're going to be taking this event right here, 18 plus 4, which is 22, and we're going to add it to the earliest time of 7. Then we have event number 8, and 22 plus 3 is going to be 25. So using the forward passing technique, we have now completed all the earliest possible times for each and every single node. Now we are going to be adding the latest completion times. Now the latest completion time, for the latest completion time, we are going to be using a technique which is known as the backward passing technique. Okay, so as we've been adding all the durations with all the earliest times, similarly now we are going to be subtracting all the durations with the earlier times. All right, and we're going to go from the last node till the first node, last node to the initial node. Okay, so once again, the default value of the latest completion time for the final node is going to be the same as the earliest completion, earliest starting point of the final node. So here we're going to put 25. Okay, this is the default value. Now for node number 7, we have 25 minus 3. 25, which is the latest completion time, minus the duration. Okay, so 25 minus 3 is going to give us 22. Then we have node number 6, and for node number 6 we have 22 minus 4, which will give us 22, which is going to give us 18. 22 minus 4 is 18. Then we move on to node number 5, and node number 5 is going to be 22. Sorry, hold on one second. Yeah, the predecessor is 7, the successor is 7. Okay, so 22 minus 8, that's going to give us 22 minus 8 is going to be 14. Now if you notice, node number 4 is not your normal node, because it is actually now a burst event. A burst event is basically a node through which 2 activities are formed instead of 1, right? So like 4 was a merge event, now 4 is also a burst event, because as you can see, activity 4 to 5 is going through 4 and activity 4 to 6 is going through 4. So this is a burst event. It is both a merge and a burst event. So what are you going to do in this? Like we had taken the maximum value in the forward passing technique, in the backward passing technique we're going to be taking the least value. Okay, so 14 minus 1, that will give us 13. Okay, and 18 minus 7, that is going to give us 11. So 14 minus 1 is going to give us 13, 18 minus 7 is going to give us 11. And 11 is the least possible value in this case, so we're going to be putting 11 as the final completion value for this. Now we move on to the third node. So this is going to be 11 minus 2, that will give us 9. For the second node, it's going to be 11 minus 6, that's going to give us 5. And once again, this is going to be 5 minus 5, so that's going to give us 0 on the initial node. So using the forward passing and backward passing technique, we have completed what are the latest and the earliest times. Okay, and earliest times is denoted by EI, latest time is denoted by LJ, and this is the formula for it, right? ESI plus the duration of the entire event, of the entire activity, IJ. And similarly, we're going to be using the minimum of the duration over here in LJ. So once we've done this, now we are going to look at the table that we are going to be creating to figure out what the total float, independent float and free float actually are. So right here you see a table that I've created. Okay, and over here you have columns, and this might seem a bit clumsy, but it's actually very simple to understand, so don't get too confused with it. First, in the first column we have the activities, and the circle numbers right here are the column names. Okay, so we have column number 1, column number 2, number 3, number 4, number 5, number 6, number 7, number 8 and number 9. We have 9 columns. Now in the first column we have the activities that have been given to us. In the second column we have the durations that has been given to us in the example problem. Then we have something known as a start, and then we have something known as the finish. And using the start and finish, we are going to be calculating the total float, free float and independent floats. Okay, now as you can see, in start we have 2 sub columns, earliest and latest. Okay, and earliest is E of I, latest is E of J. Similarly, in finish we have earliest as L of I and latest of L of J. Now if you notice in our example over here, what we have done is we have figured out the E of I and the L of J. Okay, so let me just denote this over here. E of I and L of J. We have figured out the values for E of I and L of J. So what we are going to be doing next is we are simply going to be adding the values of E of I and L of J directly into the activities, directly into the table for each and every single activity. And then we are going to take the next step. Okay, so after adding all these values over here, we are going to move on to figuring out what E of J is. And E of J, as you can see over here, I have denoted it under right here what it actually is. So E of j is nothing but column number 6 minus column number 2 for each and every single activity. So column number 6 is L of j and column number 2 is the duration. Okay, and as you see, we already have column number 6 and the durations. Okay, so the latest is going to be nothing but E of j is nothing but E of j is equal to L of j minus di of j in simple formula, in formula terms. Okay, so once again we have E of j, and E of j is nothing but L of j minus d of j, which is nothing but 6 minus 2, column number 6 minus column number 2. Okay, so 5 minus of 5, that is going to give us 0. Okay, and then we have the next one, which is 9 minus of 4, which is going to give us 5. And similarly, we are going to fill in the data for E of j. Okay, now we are going to look at the next column, which is L of I. Now L of I is nothing but column 3 plus column 2. Column 3 is the earliest, E of I, and column 2 is nothing but the duration. So in other words, L of I can be said as L of I is nothing but the sum of E of I plus dij, which is the duration. Okay, so L of I is equal to E of I plus dij, and this can be denoted a bit more easily as column 3 plus column 2. So let's just go ahead and look at this. So column 3 here is 0, column 2 here is 5. So 0 plus 5, that is going to give us 5. Okay, and then we have the next one, which is 0 plus 4, that is going to give us 4. And similarly, we're going to be filling in the data for L of I. Okay, now that we have actually completed all these first 6 columns, we are going to move on to the most crucial columns, which is column number 7, 8, and 9. Total float, free float, and independent float. And as you can see over here, I've already denoted which columns have to be subtracted. So column number 6 is going to have to be subtracted with column number 3, and all of this together is going to have to be subtracted with column number 2. Okay, so L of j will have to be subtracted with E of I. Okay, and the result of the subtraction is going to have to be subtracted with the duration, which is column number 2. So let us go back for a minute to the formulas that we have written over here. So now as you can see, this formula is going to make a lot of more sense to you. So T of TF, right, which is the total float of the activity I of j, is equal to L of j minus E of I, and the result of this is going to be subtracted with the duration, di of j. And this is the formula for it. To remember it simply, when you're solving the columns, it is very easy to remember it like this. For column number 7, always remember 6 minus 3 whole minus 2. 6 minus 3 whole minus 2. Similarly for free float, 5 minus 3 whole minus 2. For independent, 8 minus the whole of 4 minus 3. Okay, so let's just go ahead and take a quick example at this. So column number 6 minus column number 3. Okay, so 5 minus 0, which is 5, minus column number 2. So right over here we have 5. So 5 minus 5 is going to be 0. So the total float for the first activity is actually going to be 0. And similarly, we're going to fill in the total floats for each and every single activity. Now that we have finished the total float, now we are going to be looking at the free floats. Let's go back to the formula. So for free float, the formula FF was for free float FF I of j, which is the activity, E of j minus E of I whole minus of the duration dij. Okay, so E of j minus E of I whole minus of the duration di of j. Okay, which is nothing but column number 5 minus column number 3, and the resultant of this is going to be subtracted with column number 2. Okay, so let's just go ahead and do that. Okay, so in free float I made a small mistake, guys. Actually it is Li minus Ei whole minus Dij. Okay, so I had initially put here Ej minus Ei. That was wrong. It is actually Li minus Ei whole minus of Dij. So that will make more sense now actually. So as you can see over here we have 5 minus 3 whole minus 2, right? Column number 5 is earliest Li. Column number 3 is going to be Ei, and column number 2 is going to be Dij. So Li minus Ei minus the duration. Okay, so let's just go ahead and look at how this is done. So Li, 5 minus 0, which is 5, minus 5, whole minus 5 is nothing but 0. So we're going to be adding a 0 over here. And similarly, we're going to be filling in the data for free floats. Okay, and now finally we move on to the independent floats. So independent float is column 8 minus of the column 4 minus column 3. Okay, so this is going to be like this. So let's just go ahead and see it again. 8. All right, so column number 8. This is going to get a bit more confusing as you keep going on because the columns are going to keep filling in. So you have to be very, very careful. So column number 8 minus column number 4 minus column number 3. So that's nothing but free float FFij minus of E of j minus E of I. That is the formula that you're looking for. So in the first example over here, 0 minus of 0 minus 0. That's going to be nothing but 0. And similarly, we are going to complete the independent float table. Okay, and once you finish solving this, your table is actually now complete, and this is the answer for total float, free float, and independent floats. How you find this in PERT analysis? It's very simple. Don't get confused. Just try to remember the columns. Okay, we're going to have 9 columns in this. First is the activity, second is the duration, and the third is going to be the earliest start time, and the fourth is going to be the latest start time. Finish is going to be the earliest finish time, and it's going to be the LJ, latest finish time. That's 6th. Then we have 7th, which is total float, 8th is free float, and 9th is independent float. So for finding E of j, we have column number 6 minus column number 2. For finding L of I, we have column number 3 plus column number 2. Then for total floats, we have column number 6 minus column number 3, whole minus of column number 2. For free float, we have column number 5 minus column number 3, whole minus of column number 2. And for independent float, column number 8 minus of column number 4 minus column number 3. If you simply remember these simple codes, you're going to be able to figure out the entire thing very easily. So just to revise, first we took the activities and durations and we drew a network diagram. Then we put the earliest times in. Then we put the latest completion times in. And once we had done that, we moved on to the table, and over in the table we put the activities and the durations given, and we had already figured out the E of I and the L of j, so we simply put those values in. Once we had done that, using these simple codes, we evaluated the rest of the columns and we finished the table, and this is your final answer.